This is going to be your homework, and it's going to be due this Wednesday. So I don't care. Well, actually, let me correct myself. A couple of things to mention. First of all, everything I write is going to be going the wrong way, and I can write the correct way, I think. Oh, I'll try D, because I'm actually writing it backwards. That looks like a B. Okay. Anyway, what I'm going to do is just post up like a little tutorial, but you should already know how to do this because of the quiz on Wednesday. And then what I'm going to do is have on the blog the homework assignment, and that is what's going to be due on Wednesday. So basically by Wednesday you want to watch all these videos and then do the assignments. Now here is a quick review. Flying pen. Back. Here's a quick review of what we did on the quiz. Hi, pretty. And that's Susie's butt. What we did on the quiz is we said, okay, if somebody were to give you, let's say, 10.3 moles of, let's say, sodium atoms, or let's say sodium ions there. I made it an ion, which is a charge. And then they were to ask you how many actual ions in it. First of all, what are they asking you? They're giving you a mole, which is like a chemical dozen, or like we said, if I were to tell you 10 which is the little thing we made in class, then what I mean, if I'm saying how many actual ions is, you have to say, okay, well, every single is 7. So if I want the actual number of ions, I know I'm going to be multiplying. So for moles, I'm going to say the very first step in solving any problem that involves converting from one thing to another is I'm going to say, I'm going to just write down first of all what I have. Okay, I have 10.3 moles of sodium ions, and then immediately I'm going to make my little multiplication thingy. Okay. And then I have a conversion factor. Now this is where a lot of you guys went wrong on the quiz. Remember that when I'm converting, I'm not actually changing the value. It's like if I say that this glass of water that Susie was just stealing from me, and that was why her butt was in the camera, if I were to say that this glass of water was 3 real, or let's say 4 real, I could also say it's $1. I'm not changing the value. I'm giving it to you in dollars versus in real, but it's still the same value because, you know, $1 US is about 3 to 4 Saudi Arabian real. Okay? So that means that everything that goes here on this bar, and this is why we did this in class, whatever goes on this bar must be, like for example, 2 divided by 2. They must be equal values. If I said 2 equals apples, does that look like an apple? Then I could put an apple divided by 2. It doesn't matter what I put, as long as what's on the top and what's on the bottom are equal. And I know that the only way to convert from moles to single units, whether it's ions, whether it's atoms, whether it's molecules, is I have to use Avogadro's number. And Avogadro's number is 6.02 times 10 to the 23. And again, am I dealing with apples? Am I dealing with oranges? I'm dealing with ions. So in 1 mole, as far as Avogadro is concerned, 1 mole of anything is equal to 6.02 times 10 to the 23 of that thing. Now that thing I'm asking you for is ions, okay? So you're going to tell me ions. So this is my conversion factor. This never changes. Whenever I'm converting from moles to ions or molecules or atoms, I'm always going to use this. One thing is going to be on the top and one thing is going to be on the bottom. So this is what you have to memorize, okay? And then the only thing you have to ask yourself is what part of it goes on the top and what part of it goes on the bottom, okay? Now, always I said what I want goes on the top, okay? What I want, see, look at the original question. I said, in 10.3 moles of sodium ions, how many actual ions of sodium are there? I'll write sodium. Okay, So what I actually want is going to go on the top, which is this number. So I'm going to put Avogadro's number 6.02 times 10 to the 23 sodium ions on the top, okay? And then on the bottom, I'm going to put the other number, 1 mole. And the reason why this makes sense in math is because this 10.3 moles of sodium, the moles actually cancel, right? You know, moles of sodium. The moles of sodium cancel. Because remember, if in math I have something on the top and it's being multiplied by a fraction, now how I would plug this into my calculator would be 10.3 times 6.02 times 10 to the 23 divided by 1, which you don't even have to do, and you're going to get your answer. I don't even care what the actual answer comes out to be. All I care about, and this is the other thing that's really important, you don't even have to use a calculator as far as I'm concerned. I really don't care. On the midterm you will have to, but for all of the quizzes and stuff, again, I don't care. I'm sure you know how to use a calculator. All I want you to do is put a box at the bottom like that. That's going to be your number, whatever the number comes out to be, okay? So that equals some number, whatever that number is, and then I just want you to put the units. And the units of my answer are sodium ions. Okay? So that's how you do that.